Welcome to the second week of ML Practices course. And in this session, we'll be covering activity and practice questions. Uh, the topic of second week is dominated by uh, data pre-processing. Okay, so data pre-processing is uh, there to solve some of the problems which the data comes with. For example, so what kind of problems could be there? So somebody who recorded the data, there might be uh, some issues. For example, he missed to fill some values. Uh, Other problems could be he missed and mistyped some of the numbers or some of the values. So these are the problems from data entry points. The other side of problems could be the data is not in a suitable format to be fed into a machine learning model. For example, there are string values. There's a column called city, imagine, and there are values like Delhi, Chennai, Mumbai, and so on. But the machine learning models only expect numbers. But these strings are not just numbers yet, so that they can be fed to a machine learning model. So because of so that is one, and another could be so machine learning models work really well with if we talk about numerical features, if the features are well scaled. Imagine in a data set there could be one feature which ranges from, let's say, 100 to 1 million, and there could be another feature which ranges from, let's say, minus 20,000 to minus 10,000, something like that. And for so if we take an example of gradient descent, so uh, descent algorithm is very much affected by the scale of numerical features. At least its number of iterations it takes to reach to the minima. So if we scale the data before we feed the model, before we feed the data to model, that is going to bear fruits for us later in the training period. So because of all these reasons, we want to look at the data and put it into right format so that it is easily consumable to machine learning model. Any questions so far? I hope that you have watched the videos before this session and at least have a try at these activity and practice questions, or gone through them at least once. It will be easier for you to follow and get the idea of it. No comments, no questions.
I have not watched the video, sir, to be honest. Didn't catch up yet. But I'll follow along.
Okay, okay. To get the best out of these sessions, it is better to go through the activity, first watch the videos, and then go through activity and practice questions before you come to this session, because that is then you'll make most out of these kind of sessions.
Yeah, I
So
agree.
I
Yeah.
have a couple of general questions on this. Can I ask?
Yes.
Okay.
Yeah,
So
sure.
yes. So in case of feature scaling, the standardization and normalization both processes are there. So how to know the which process is correct for a particular data set? Is there any rule behind that?
Yeah, we'll come to that point, definitely.
Okay.
uh, Pranav had a question. Yeah, Rakesh, I assure you, when we come to the scaling part, I'll answer this question.
Okay.
Yes,
Yes,
Pranav.
sir. Yes, sir. So actually, I had a question about label binarizer and one hot encoder because they almost generate the similar output. But what is the difference between both of them and when to use them?
Mm, okay, okay. For that, okay, we'll come to that also when we come
Okay.
to feature, dealing with categorical features.
Okay. Thank you, sir.
Yeah. All right, so let's begin. So in each of these kind of sessions, we will assume the instructors will assume that you have watched the videos. That's an assumption we are going to make, because going through the videos and then covering everything, activity questions and practice questions, will be really difficult, and to pack in 2 hours. Okay, so let's begin with the assumption that you have some amount of idea of what has been discussed in videos.
Excuse me, sir.
Sure.
Sir, I have a doubt regarding the questions in quizzes. As I have seen so far in the both of the graded assignment, the question has been given from. We have a link and we have to open that file, and we have to open that some collab or something and do some operations on that. So.
Mhm.
In our quizzes also, do we have the same kinds of questions, or the questions might be different there?
So to get so you're talking about quizzes, or to be sure that you're not talking about OPP?
No, sir, I'm talking about quizzes only.
Okay, okay. So quizzes, I think you can get some idea about quizzes by looking at the past papers. Okay, this is going to help you, and of course there would be the questions would definitely involve questions like this. The pattern of the questions in quizzes will be very similar to what you have been already asked in activity and practice and graded questions.
So, sir, there we need to have some collab work. We have to do some collab work in graded and practice assignment. So, in
Okay,
quizzes also, we'll have to do the same thing. I just want to ask that part.
right. So in quizzes, you will never be required to write any code and produce answer. Mostly they will be some description of the question and set of options, or a place to enter number. That's all.
Yeah, because activity questions, we don't need any collab or something. We just look at the questions and have the concepts in our mind, and we are good to go through the answers. So, it will be the same procedure there in quizzes. I just want to confirm that.
Yeah, that's right. That's right.
Yeah,
Uh,
okay. And sir, in OPP, we'll have the questions like graded and practice ones.
in OPP, the questions will be, yeah, you can assume that. Yeah, yeah. Practice assignment and graded assignments, that will be the pattern.
Yeah, okay. We'll use collab there.
Exactly.
Okay, okay. So thank you for that.
Sure. All right, let's go to the first question. What will be the output of the following code? So we have a variable called data, and it's an array of multiple dictionaries, right? Seems like every single dictionary inside this is actually a row, right? So it feels like that the first course is opted. So you can see that the key courses opted in GPA is common to every row, and it feels like that this is the name. This should be the name of the column, and this should also be the name of the column. Courses opted and GPA, and the values which are associated, 4 and 6.7. This forms one row. 4 and 8.5. This also forms one row, and we can proceed with each one of these examples. And there is some code from sklearn.feature extraction, import vectorizer, db data transformed. So we apply this fit transform method of data vectorizer, which is not going to only fit the transformer, but also transform the data at the same time. So fitting is like learning the parameters of the transformer, and transform is like actually applying those values to maybe the data that you have already read, or to new data. So any take guess, what should be answer for this?
First option, sir.
First option. So first, okay, let's see. 1, 2, 3, 4, 5. 5 rows should be there. 1, 2, 3, 4, 5. I think that is relatively easy, because you don't even have to look at the values. You just count the number of rows and it will work.
Yes, yes.
Excuse
But
me,
of course,
sir.
yeah.
I have a question. Can I ask now?
Give me 1 minute. I'll just say one statement about this. But at
Yeah.
the same time, we can also confirm the values which are there in the original data in this one. So yeah, this is the correct answer. Go ahead. Somebody has a question.
Yeah, sir. Like, I have a question. Like, once the transformer is fit, so then like again if you have to use it in the like say test data, so again we have to fit the transformer, or directly we can just transform it.
Um, sorry. So
Did you get
there
my
are two
question?
steps. One is fitting, one is transforming, right?
Yeah.
So these are two logical steps. Even though sklearn allows you to call fit underscore transform on transformers and get the execute both the steps together, but logically they are two steps. So you fit the transformer only once, any transformer. During your typically this is what happens. You fit a transformer on any data only once during your entire project cycle. Right. So when I say cycle, you started by reading the data pre-processing, modeling, feature selection, and so on, and producing the results. This is what I mean by ML cycle. So in this cycle, you use fit method on a transformer only once, not more than once. Because if you do that, you run the risk of making mistakes. So
Okay.
let's talk about any scaling, min max scaling. Okay, so you use that scaler on training data to learn the parameters, and of course you transform training data also, but you never fit that transformer again on test data. You just transform using this new already learned transformer. So this is what the typical cycle looks like. Does it make sense?
Yes, sir. Yes, sir. Yeah, clear.
Okay. Because can you guess what is the reason behind it? Why don't we fit the
Because it's
transformer
already
again on the
been
test
like
data?
learned, like how to we transform it. This has already been learned. So again, I think we did need not to do that again.
See, biggest assumption is the test data or any unseen data is also coming from the same distribution which is generating the training
Yes.
data, right? So if you apply any kind of transformations on training data, to make sure that it is properly, the test data also lies in the same space, right?
Yes.
We have to just transform and apply the transformer on the test data. We never fit that new transformer or the original transformer on test data.
Yes. Yes. Yeah. Makes sense. Yeah.
Okay.
Sir,
Uh,
sir, I have a question on this.
Sir,
Yeah.
question one fetches only two rows, right?
Question one. Oh, right. You are absolutely right. This line I forgot to say. Yeah, it should return only two values. For this one, I think, yeah, this one should be correct.
Sir, what I was saying,
Yes.
in case of you missing data, when you put some mean value or median value, actually we are changing the distribution. So is there any
Right.
other way? Is there any other way? Like if you change the distribution, it may not be the actual one.
That is, yeah, absolutely possible. So your concern is that when you use imputation, for example, mean or median,
Hmm.
the original distribution might not be same as transformed one, right?
And also a couple of data which was part of earlier part of distribution, it will show like your outlier. Okay, because
Okay.
so is it the only way, like, or there's the other, if you can put random values so that we can maintain the distribution.
See, I see your point. So, couple of points. There, using mean and median are not the only ways to impute values in dataset. Second, random values will, produce the same problem, right? Random values will not represent the original distribution. The
Okay.
third, the option that I wanted to talk about is, so it's slightly tricky, but definitely doable. So imagine that you have 10 features, okay, in one label. And out of these 10 features, there are two columns there are which have missing values. And assume that all of them are numerical for the sake of simplicity. Okay. Hello.
Yes, yes, you're audible, sir. Yes.
Now, take the rows which don't have any missing values.
Okay.
All right. and remove the last two columns. Consider now this small. Now you have a smaller machine learning problem inside a larger machine learning problem. Now what you can do is you can use the first 8 non-missing features with non-missing values as training features, and last two columns as labels, which have missing values.
Okay.
Okay, so the rows which don't have any missing values, you can use that as a training data, and the rows which have missing values, uh, consider them as test data.
Okay.
Okay, so the missing values are predicted by any model which you think is suitable, decision trees, SVM, or anything.
Okay.
Make sense?
Okay. So then we have to that for those column we have to make another different machine learning. After that, getting this data, then we have to put it in the final machine model, right?
Yeah, absolutely right. Right.
So it will be very like tedious job, sir. I think for same thing you have to do twice. Is there any other way, like or like any imputer is there so that they can predict automatically? Is there?
See, KNN imputer is also there, but of course, KNN imputer is also based on a K model, which is KNN.
Hmm. Okay.
Okay, so that's why I did not say it separately. KNN, decision trees, and everything. All these are model-based approaches you can use. They are more likely to, resemble your original data distribution.
Okay. Okay. Thanks.
All right. Yeah. Let's move on. Question number 2. Which API provides functionality to fill missing values in a data set? SLN impute, SLN fill missing value, extraction, data vectorized.
So sklearn impute.
Yes, absolutely right. This is the module which has the set of APIs. Question number 3. Which of the following methods is used to replace the missing values of a feature by the average of all values of the same feature? Simple imputer, strategy median. Imputer, strategy median, simple imputer, mean, imputer, mean.
So third.
Third option, right? So simple imputer, strategy mean. I think the name gives away. It has very basic ideas of imputation: mean, median, most frequent, and things like that.
So mean remains default by default strategy, right, sir? For
What
simple imputer.
I think so, but we can check the documentation also.
Okay.
Right. Question number 4. Import numpy as np from sklearn.impute import simple imputer. Okay, this is the code snippet. What does it do? Missing values np.nan strategy median. What will be the missing value in X after the execution of the above code? Okay, nice.
Six, I think.
Right. Everybody agrees with that?
Sir, I have a doubt in this.
Yes.
Go ahead.
Sir, in the question, it says strategy as median, but the
Mhm.
answer is coming as 6 on doing the average, like the mean. So, sir, how is it correct? Like,
Correct. So, see, this example does not have sufficient number of samples to distinguish between the possible outputs of median and mean, right? So, how do you compute median if the number of samples or number of data points is even?
n by 2?
No, you don't do n by 2. N by 2 is when you have odd number of data points.
Average of middle two number. If
Right. What we do is we choose the two middle numbers, right? Will at the center. So let's say if I have 10 data points, then I choose fifth number and sixth number. They are close to the middle of my data set, right? And what do? I take the average of those. Correct.
Yes, sir.
Right. So in this case, what happens is the number of data points is only 2, 4, and 8.
Okay, sir.
And hence, if you take the average of that, it seems like that it is doing the work of a mean strategy. But yeah, in this, the example is too small. both of them will produce the same answer.
Okay, sir.
So I have a doubt here. So in median thing, we have to arrange all the values in some order, like ascending or descending, and then
Right.
we'll compute those missing values or something, the median thing.
Right.
But here we are not doing this thing, and I know in this example it's not required, but in longer example, how should we arrange them in order, and then how should we go on for that if we have to arrange them in ascending order and do the median then?
Very good question. So actually, all of that has been taken care by this simple imputer. As soon as you mention strategy is equal to median, it will internally maintain an array and sort them out and figure out what is the median value.
Okay. Okay, sir.
Okay.
But sir, in this kinds of question where we need to do the things like here we need to get the answer 6, then how should we go on for that? How that does it works internally?
See, if you want to do it, I think you can just look at the columns 4, np.nan, and 8. There are only 3 values. One is missing, so it must
Yeah.
be average of the rest of the 2. Internally, I haven't seen the code for this one, but I'm pretty sure if you want to calculate the median, you'd have to use some algorithm. So either definitely simple imputer would make a copy of first column and then compute, remove the missing values, of course, np.nan, and then compute the median, and then use it to fill all the values, all the missing values with that median.
Okay, so sir, if there were numbers like 4, 8, 6, 12, then it would arrange them in ascending order and then do the mean and then put the values np9 equals to that median.
Right. I wouldn't say exactly that algorithm, but some median finding algorithm.
Yeah. Okay. Okay, sir. Thank you.
Yeah. Any questions so
Sir,
far?
it is the number of total number of data points or data points except np.nan.
Sorry, please repeat that.
In main, okay, it's median. Okay, sir, it's median. I thought it's mean.
Okay. Okay. All right. Let's move on to the next set of questions. Okay. This is consider the following feature. So this question, this is about, I think. Okay. So lecture 2.2 is about numerical transformers. So I think we are going to get questions from there. All right. Consider the following feature vector. What will be the transformed feature matrix x dash after standard scalar transformation?
Sir, second option.
Okay. So can anyone tell me the formula for this standard scaling?
So it's x dash equals to x minus mu upon the standard deviation.
Exactly. And what is the mu for this?
So it's 3.
Right. So if you subtract 3 from all the elements of this vector, we are going to get minus 303. Yeah. Second answer may be right. And what should be the standard deviation?
√6.
Root of 6. Yes.
Yeah.
Second is correct by all means. Question number 2. The new feature matrix x dash using transfer of min-max scalar is obtained as.
So option 3.
3.
Right. Right. So the denominator mentions the span of the entire feature, and we divide that. That goes in denominator, and the numerator is any new data point divided subtracted by the mean. Okay. So can anyone tell me what is the range of this?
0, 1.
Absolutely right. No, 0 to 1. So maximum value will be represented by 1, minimum value represented by minus 0. Next question. What will be the output of the following code from scalar import max absolute scalar? Okay, here we are using max absolute scaling.
So just one clarification on the scaling part.
Mhm.
Whenever we use any scalar, we have the value ranges ranging between 0 and 1.
Sorry, the output you are talking about or the input?
So the output.
Yeah, absolutely.
Okay.
No,
Okay, sir.
sir, no, not all the cases you have to 0 to 1. It's maybe max mean, but for for standardization, I think they don't need. It can be anything.
Right. She's talking about min max, right? Or all numerical transformers.
Sir, I was asking about all the numerical
No,
scalars.
no. Range for different transformers is different.
Okay. So for min max, it's 0 to 1.
Right.
Okay. Okay, sir. Thank you.
Then max absolute scalar, it has different range, -1 to +1. And one of them will is likely to be skipped. Okay. Question number 3. What will be the output of the following code? Max absolute scalar. Y is equal to 2, 8, -4. Yeah, we got the, see, what we were talking about, we just got an example of. So what should be the output of this?
So it's D.
Which one?
So D.
D. Why?
So because in max absolute scalar, we take x dash equals to x upon the max absolute value, and here
Mhm.
max absolute value is 8. So
Absolutely
when we
right.
divide everything by 8, every data point, then we get the same answer as D.
Okay, imagine there's just one change. Instead of 8, there was -8. Everything else same. What should be output then?
So then also the same output will be there.
No, something will be different.
So
Sign will
sign
be
-1.
based.
Pardon me?
So it will be -1, sir. Then
Exactly. So the middle value will be -8 will be replaced by -1.
Okay, okay, sir. Okay. I
Because
understood where I was mistaken.
yeah, because what you do is you take the absolute value of you take the absolute value of all the items in the vector and take the maximum of those.
Yeah, okay, sir. Right.
All right. Question number 4. What will be the output of following code? For masculine represent function transformer. Great. And we got this.
Two.
Right. 2. Exactly.
Sir, I have a doubt here in this question.
Mm-hmm.
I was expecting like it to return 3 in array, 2 in array.
Mm-hmm.
So why it is not happening here? Because
Mm,
if you give like log or something, it
uh-huh.
will return like log of 1, log of 2, log of 3, right?
Right. Good point. So see, log is a function which is applied on every individual item. It accepts an individual item and returns an individual item. Numpy.mean is a function which accepts an array,
Yeah.
right? And gives you a single output. Right? One vector, so output is only one value.
Okay, okay, right.
Okay, because of that.
Okay, so if we give some axis or something, then
You should try it.
okay, okay, I'll try. Yeah, sure.
Okay. Any further questions so far?
sir, one question that whenever we put data to any transformer or in anything, do you have to put it in array, or you can, if data is your data frame based data, so can we put it in a data frame structure also?
Good news. We can do both. So function transformers, not sure about function transformer, but column transformers and pipelines, they can directly feed on data frame.
Okay.
So just clarification here about the fit transform.
Right.
First we do the fitting, then we transform the vector. The reverse is not true, right?
Reverse, what will be the reverse of this?
So first transform and then fit.
See, if you try to transform using a transformer, an object which has not been fitted, that means its internal parameters have not been learned, you will get garbage.
Okay.
So definitely yes, we never do the other way around.
Okay, so thank you.
So what I was referring to the few minutes ago is Uh, you fit your transformer only on training data, and on test data you only transform. Okay, you never do fit transform and test data. I see this mistake many times, that is students think that apply fit transform and training data as well as on the test data. It's a very wrong practice, and it can lead you to very incorrect outputs and expectations from your model.
Okay, sir. Because in fitting data is being the model is being learning, and in transformation it's just applying the learned model. So
Exactly.
in the test data we don't need again to learn the model, because the model has already been learned. So we just need to apply it to the test data. Is this the thing that I'm like?
Correct. But when you say model, it's not a machine learning model. It's only a transformation model, right?
Okay, sir.
Yeah, that is correct.
Okay, sir.
All right. So somebody asked a question about why do we use standard scaler, or when to use standard scaler versus when to use min max scaler or any other scaler.
Yes.
Right. So see, standard scaler. Okay, I'll give you one point and you will say, okay, now you understand it. So what kind of data this standard scaler will be suitable for to apply transformation?
Normally distributed data.
I think
Absolutely right. Absolutely right. So for the data features which are normally distributed, this is very useful. This is going to give you very good results and transform the data more naturally. And min max scaler for everything else, min max scaler, max scaler you can work with.
Sir, min-max scaler can be used in we have a rating or something like that. Then we can use it.
Of course, you can
Okay.
do that.
Yeah.
I think so. If your data have a lot of zeros or none values, so that point of time the standard scaler is suitable, or mean max scaler.
Am I audible, right?
Yes, sir, you're audible.
Okay. So can you repeat your question?
So my point is that if your data have a lot of non value or maybe zeros, huh? So that point of time standard scaler is suitable, or min max scaler is suitable? Will be suitable.
Well, look at the distribution. If it has null values, first of all, you cannot apply this transformation. You have to impute it first.
Okay. If it is a lot of zeros are there, or maybe the lot of outliers are there, then
Right. If a lot of outliers are there, standard scaler is possibly not a good option. You should use a min max scaler or max absolute scaler. Okay.
okay, sir.
Yeah. All right. So let's go to next set of questions, which is categorical transformers. All right. Consider the following feature matrix. What will be the dimension of the transformed feature matrix X dash after one hot encoder transformation? Any takers?
5 by 4
Yeah.
because there are
5 by
5
4.
rows and 4 unique values.
Absolutely right. That should be the answer. Therefore. So just a quick comment on this. One hot encoder is going to create it is going to increase the number of dimensions. And how many columns it will create? Will be equal to the number of unique values in this vector. So 1, 2, 3, 4. So yeah.
For dummy variable, we need to train n minus one variable, right? For fitting.
Please repeat your question.
So means for for fitting, we need only n minus one variable. So 1, 2, 3. Answer should be. We need only three variable. We need to remove one column from data, right?
Okay, why is that? Why is that?
Um, because yeah. Uh, means no means somewhere read about we need to train your n minus one variable. So I just confirmation is it true or
Well, mm,
So I
you
think
can, but it's not necessary. See, imagine that. So I get your point. You are saying that 1, 2, 3, 4, these are the unique number of values. And if we, let's say, remove the first column, right, to determine whether one is this sample belongs to one or not, basically it will have all zeros. The
Yes.
vector for this feature will have only zeros, right?
yeah.
Yeah, you can do that, but I'm not sure what gain you're going to get from there. Just reducing the number of dimensions, is it?
Yeah,
Sir,
read direct reduction, yeah.
he's talking about the dummy variables, sir.
Pardon me?
He's talking about the dummy variables, right?
Yeah, yeah. So
Yeah, yeah,
the 5 by
then
4 vector you get, you can remove, sorry, 5 by 4 matrix you get, you can remove one of the columns.
Yes.
Yeah, you can do that depending upon the situation. If, one means absence of something, all the others, probably, yeah, go ahead with this.
Also, it's used for the collinearity. I think they reduce the collinearity between these columns. I think that is also one purpose they use it.
So I did not get that point.
Generally, for collinearity, to reduce the collinearity, they use it because if it's a five I think if you have a like four, if you reduce one, it becomes zero. So it reduces the collinearity between these columns. So that is one of the reason that it may be using.
Okay. Okay, if collinearity is what they are trying to reduce, okay, we'll come to a general method of reducing dimensions. No worries. Okay. Question number 2. Consider the following categorical feature matrix X and its transform feature X after the multi-label binarized transformation. Which column in X dash refers to diabetes? So there is one, okay, there are 1, 2, 3, 4 rows and single column, but each column is actually seems like a dictionary or set of items. Set of items more likely. So yeah, which column refers to diabetes?
So the third column.
The third column. Okay. So yeah, you're right. That's the one because it's 0, 0, 1. Nothing else is there, so it should be the third column.
Excuse me, sir.
Yes.
So could you please scroll up a bit?
Mm-hmm.
So little down. So question number 2.
Mm-hmm. Okay. This is the question number 2, right?
Yes, sir. So in these kinds of questions, we have suppose we have heart disease. So what I do, I place this on the first column, and diabetes. Generally, I place this on the second column, and then we see the new data, high BP. So I placed it in the third column. That okay, the third column represents high BP. But here, it's not having an order here. So
Mm-hmm.
generally by seeing two or more data sets, suppose the line 1 and line 2 says the heart disease diabetes and line 4 says diabetes. So I just looking at the data, I get to know that diabetes might be the fourth column, but here
Mm-hmm.
no order is following. So how could it generate it without any order?
I'm not sure if it uses any kind of order, or we can provide it order if we want to. Um, but if we don't provide it, will take. I'm not sure. Maybe it takes the a random order. Can anyone correct me on this? See, here it is also not mentioned what order it chooses.
So I
As
just
far
want
as
to know how it functions internally, because generally just like we humans do, we place the first thing at the first value and the second thing at the second value, but it's not doing the same. So how is it performing internally?
For that, I think we'll have to look at the source code of this. This is a long wieldy code, definitely readable. Would you like to try that?
Okay, sir.
So honestly, even I don't know the answer to this question, uh, and it is not mentioned in the documentation itself. Right? I don't know how it does that. So the best way to figure out is looking at the code. Might consume time a little bit, but it can be fun also if you enjoy reading code.
Yeah, okay, sir, I'll do that. Thank you.
Yeah. All right. Question number 3. What does the transformer label binarizer do? Converts multi-class labels to binary labels. Convert multi-label feature to a binary label. Encode categorical features with value 0 to k-1. Encode categorical features with values -1 and 1.
Sir, first option.
First option.
Right. Multi-class labels to binary labels.
So
So
what is
multi-class,
the difference between this label binarizer and one hot encoder? Is it doing the same thing?
no, they seemingly do the same thing. One-hot encoder, I think it accepts only columns, right? However, label binarizer, it accepts vectors. Oh, okay.
Okay.
Let me be a little more clear. So label binarizer. Imagine that you want to predict for a movie which um, genre it belongs to. Okay, let's not worry about the features as of now because we are only talking about the labels.
Yeah.
So for predicting the genres of a movie, for one movie, for example, let's say Three Idiots, you will
Yeah.
find that the genres are comedy, drama. Okay.
Yes.
Other could be, for example, let's say Batman. So it could be action and drama, right? Comedy is definitely not there, or I'm not sure. So imagine this kind of situation. So the label column is going to have multiple values in multi-class problem.
Okay. Okay.
Multi-class, multi-label problem.
Yeah.
Okay. So in this situation, label binarizer is going to create multiple columns, of course, just like one-hot encoder, but the output for every value will be a vector where more than one items can be present. Others are zero. One-hot encoding,
Yeah.
every
Only
row
one.
only one.
Only
Uh,
one. Yeah.
yeah, only one is present. Everything else is absent.
Okay.
Right?
Yeah. Got it.
Okay. What will be the output of following code? Import numpy as np from sklearn.impute import simple imputer. Uh, from sklearn.preprocessing import add dummy feature. Okay. IMP is equal to simple imputer. Strategy is mean. Then this is and this. So what it is asking is, uh, this is our data. We apply simple imputation on that with mean strategy, and after that we add a dummy feature. And what will be the output of this? Any takers?
Yeah. It will add a dummy column at the beginning, and then it will replace the name value by the mean of that column. So
Right. So what should be the NaN value for this?
it will be 6. Yeah, 6 will be
6,
the.
right. So we are seeing 6 only here. There is NaN, which is not acceptable. We are seeing 6 also here.
But we need a column there of 1.
Absolutely right. So first one is missing the dummy feature. Second one is missing the imputation. Third one is the correct one. and fourth one is incorrectly calculating the missing value.
So I have a doubt regarding the dummy features.
Mhm.
Why we use dummy feature and where do we use dummy features?
Good question. So let's talk about some. For that, I have to tell you a few things about some of the models. Let's say we talk about linear regression. Okay. So imagine that you're fitting a very simple line y is equal to mx plus c. All right.
Yes, sir.
So what happens is you want to figure out, let's say, there are two columns, temperature and let's say humidity, only these two. Okay. And the
Yes.
temperature is your, let's say, mm, feature, and humidity is your predictor or unknown label vector. And you want to figure out a relationship between these two, and that too, very simple one, y is equal to mx plus c, kind of. Okay.
Yes, sir.
So when you fit a model, you feel the need for a constant value if you want to find a linear relationship between these two quantities, right?
Yes, yes.
And for such cases, we have to add a dummy feature. A dummy feature is basically just one, so that whatever the multiplier of whatever the weight or multiplier of this column will be, that will be your C, constant value of the model.
Okay. So the dummy feature would act as what, like y equals to mx plus c. We have the equation. So where in this equation fits the dummy feature?
So dummy feature, see, dummy feature will be it's called dummy because it is not coming from original data source. Okay. And it is being added for convenience so that it can represent the constant term. It is always one. Dummy feature is always one. Okay.
So wherever we need to place a like relationship, a linear relationship, we use dummy features.
uh, Roughly you can remember it right now as like that, but when you will study let's say linear regression later, you must have studied linear regression in MLT also, right?
Yeah. Yes.
So there would also, you would see x0 or theta0 kind of terms, right?
Yeah. Yeah.
Yeah, so x0 is your dummy feature.
Okay. Okay. So okay, understand.
Right. And you will also see an example in MLP as well when regression week comes in.
Okay. Okay, sir.
All right. Question number 5. What will be the output of the following code? We have a label binarizer. Yes, yes. No, yes.
1101.
1101. Right, this one. So basically, 1101. No. Right. So label binarizes, I think it orders the items into increasing order, the unique values, and then gives them values starting from 0. Okay. Okay. Any questions so far? All right. Let's go to next set of questions. So this is filter-based methods. So this comes under feature selection. How do you uh, select the importance of some of the features? How do you choose to remove some of the features or retain some of the features based on some parameter? And we'll come to that. Which of the following are the APIs for the feature selection based on the filter-based methods? Anyone?
Variance threshold will be there, and select percentile will also be there,
Okay.
and select from model will not be there, but I'm not
Mhm.
sure about the RFE.
So recursive feature elimination also uses a model inside.
Yeah, okay, yeah.
Yeah, I think also these two should be correct. What task does the API variance threshold do? It removes all the features with variance below a certain threshold from input feature metrics. Removes all the features of the variance with variance above a certain threshold from input feature metrics. Only removes all features with zeros variance. Normalize the features to reduce the variance.
First one, sir.
Right. First one should be correct one. So it's like the definition of variance threshold. So certain features, the number of values or the exact values inside that feature is not changing by much. Definitely, it is. Probably it is not adding any information to your data. So we can use this to filter such kind of columns out. What tasks does the API select k best do? Removes all the k highest scoring features. Removes all the k highest removes all but the k highest scoring features. Removes all but a user specific highest scoring percentage of features. Removes all user specific highest scoring percentage of features.
So option 2.
Option 2, right. So it's as the name suggests, I'm selecting k number of best features from a set of features. So how it's done? It calculates the score for every feature and arrange them in decreasing order and picks the top k features.
So how it is calculating the score? I mean, score is like where it is getting the score.
I believe it is computed select k best. It is computed upon by uh, computing the score between every feature in the label vector. What function exactly it chooses? Let's see.
Okay. I think in the lecture, sir mentioned about chi square or something like that. I think.
Right. Those can be definitely useful functions for this. Default function, scoring function is not mentioned over here. Right. Function taking two arrays x and y and returning a pair of arrays, scores and p-values, or a single array with scores. So yeah, either we can use chi square function or any other scoring function that can give us a score or number. The higher the better kind of function, and we can use that to figure out which features are the highest k scoring features.
Sir, so let's say we are selecting the chi-square for this. So like it will do the chi-square test between the feature and the label, or among the features it will do?
No, feature and the label.
Feature and the label. Okay.
Right. If it does it amongst itself, then how it's going to score itself?
No, I'm saying like among the, like, let's say we have a 3 feature. So among feature, I mean feature 1 and feature 2, it is doing the chi-square, and if it is the score is let's say very low, then we can remove one. Something.
Okay, look at this example. Okay, we want two number of features and we are doing fit transform in x comma y. X is the feature matrix and y is the feature label.
Okay.
Right, and you see that we need both of them to select the k best. We cannot just do with the features only.
Okay.
Right, so ultimate how the importance of features uh, relevant for selecting the k best features. The most important ones are going to contribute more towards the prediction accuracy, right?
Yeah.
Right, and for that we definitely need the labels.
Okay. Yeah.
Okay. Question number 4. What will the following code implement? Transformer, generic, univariate, select, chi square function, mode is equal to k best, parameter is 20, x this. Okay, what should be the output of this?
It's giving the parameter, so it should be a number. So 20 best features based on the chi-square squaring function. Third one, I guess.
Correct. So it's basically select k best with chi square function as a scoring function and k is equal to 20. Question number 5. Which of the following options is are correct about the scoring function in univariate feature selection methods? Uh,
So the first one, and
mhm.
if statics can be used in both classification and regression. The fourth one.
Okay.
So I have a doubt here, like why it is true. I mean, the first one, uh,
Uh,
chi-square can only be used in classification problem.
okay. Let's look at the function. I think this is maybe I should have looked at the SQL part. See, it is it is used between one numeric feature and the other has to be a class.
Okay. Between.
Okay. If you like to read more upon that, definitely you can look at its definition, its curves,
So
and
then features also need to be categorical, right? Because if we want to apply chi-square test, then features also need to be categorical, I guess.
not necessarily.
Excuse me, sir.
Yeah.
So I want to comment on this chi-square test. So
Mhm.
as far as I remember in statistics too, we have some part related to this chi-square test. We have two kinds of hypotheses here. One is null hypothesis and another is alternate hypothesis. So if null hypothesis is true, we accept the null hypothesis. If it is false, then we reject the null hypothesis. This is kind of thing that we do in here in chi-square.
Yeah.
So that's why I think we use classification here because we get the Boolean values here. Either we select or we reject. Is this the true or not? Like I want to clarify myself.
Uh, okay. So it is slightly different situation because what his question is, what will be the input of the chi-square function? Am I right?
Sorry, sir.
What will be the input of the chi-square function? What will be the nature of the inputs
Yeah.
x and y to the chi-square function? Right? Yeah.
So initially he asked about why it is classification, so that's why I thought that might
No,
be his.
yeah, classification is kind of clear, but as far as I understand, like both the input should be categorical. Otherwise, chi-square test cannot be applied because in chi-square test we are checking the independence, like right, chi-square test of independence we do.
I
Right.
think
So
numerical is all can also be possible here. The numerical values must not be categorical. Like I think I don't know I'm right or not.
see, it is. I would say two things. First, the documentation says that it has to be one thing has to be a class. And if you want to look at more into this, look at the source code, how it's implementing. So what you must have studied must be a mathematical model. It might be general in nature. Look at this one, how it's internally implementing that. Does it accept numbers and numbers or numbers versus classes? Okay, so see, many times you will find that, and it is true, we still do that. Many times when you have questions, the answer you were so specific question, the answer is not written in the documentation page. So the
Yeah.
best way to decide for yourself is look at the code. And trust me, we have found some interesting behaviors from looking at the code, which were otherwise unexplainable by just using them.
So how to read this? I mean, just from the source code we have to.
Yeah, source code. Look, so first of all, most of the things, you see these things over here,
Okay, it's
they form really good documentation, nodes, returns, parameters, and everything. So this is a very good documentation. Then I think that it is start finishing over here. So the entire code sits between these many lines. Oops, what is this? Yeah, these many lines.
okay, sir. Yeah.
These. Okay, and of course there are comments also. Many times what you will find is if you look at the sklearn code, there are a bunch of functions you use like this underscore chi-square.
Underscore.
Okay, so which hide away the actual implementation, but it is easy. You can click that one, and either you can go to that definition of that function also, and now there
It's
it
a, it's
is.
a it's a private method, right? I mean, the
Right,
underscore is here.
that's intended to. Yeah, underscore is meant for that.
Okay.
Right, and now you have the actual implementation. Exact implementation. If you look at this, you can figure out what you want to know.
Okay, sir. Okay, yeah, I'll look into it.
So for x and y, the y might be the Boolean value, so it is categorical, I think, here in this
Right,
sense.
right.
And x can be any, like numerical or categorical, both.
Yes, I think so.
Okay.
All right. Coming back to our set of questions, what will be the output of the following code? From sklearn.feature selection, code threshold, variance threshold, and just use this. Okay. So we have a data of 3 by 3 size, and we're applying variance threshold. What should be the output of this? Anyone?
Variance threshold. I think I have to implement this. Otherwise, by looking.
Right. One thing you can do that is you can definitely implement it, or the other thing that you can do is look at the documentation of this. I think these kind of questions can easily be uh, solved if you know a very small point which is necessary. So default value for threshold is 0.
Oh, 0.
Okay. So all the features which have variance 0, that means all the values in that column, those columns are zero, same, right, across the entire columns. Then that column is actually removed. So do you see any column in this data which does not change across rows?
The first one, first column.
Right, first one, 111. So that has to go, and that goes away. That should be the correct answer. Okay. All right. Any questions so far?
Sir, I have a question, like it's not related to this like lesson.
Mhm.
So in OPP, like we can look into the documentation or not? While
During OPP, can you look at the documentation? Is that your question?
yes, yes.
Yeah, definitely. There are two ways to do that. One is we are going to provide you one PDF file, which will have the overview of all the, I should say, all the important APIs that you need to know to solve that OPP.
So we have
That is one.
to remember it, or we can look into it, like
Yeah, you
the
can look
before
into
exam.
it. You are allowed to use it.
Okay, okay. So it will
Okay, but
be like
only that reference, not sklearn documentation.
sorry. Oh, only that reference only we have to we can access it.
Right, right. You cannot access sklearn documentation.
Yeah, yeah. Okay, got it. Okay.
Okay. And the other method is if you have used Colab, you must be familiar with the auto completion
Yeah,
and
yeah,
help
yes.
functions. Right, so you can use them anytime.
So it will be on Collab, right? Not in the portal.
No, it will not be on portal. It will be in Colab. So it will be mix of both. To be more specific, you will solve the problems in your collab, and whatever the answer you get, you are going to feed that or write that data or write that answer into Portal.
Okay, sir. Okay.
So Portal is going to record your answers, and the work that you need to do will be done in collab.
Okay, sir.
All right, let's go to next set of questions. So next will be based on wrapper-based feature selection methods. All right. Which of the following options are correct about the recursive feature elimination? It is a filter-based feature selection method. It's a wrapper-based feature selection method. RFE works by searching for a subset of features by starting with all the features in the training dataset and successively removing features until the desired number remains. Selects desired number of important features as it's provided by the max features parameters. A parameter above certain threshold of feature importance as obtained from the trained estimator.
Second and fourth, I think.
Definitely, it's a wrapper-based method. Fourth, select the desired number of important features above certain threshold of feature importance as obtained from the trained estimator. For sure, fourth and not the third one.
I'm not sure. I mean,
Anybody else?
because in the third one, it is only looking at the features. I mean, not on the model.
So I think the third one is right.
Right. RFE works by searching for subset of features by starting with all features in training dataset and successively removes. So when it says successively removes features until desired number of feature remains, this sounds correct to me.
Okay, okay. So I was saying because if it is a wrapper based, so it should have a like it should use a estimator, right? I mean,
Yeah, so it doesn't say it is not going to use any estimator, does it?
okay, okay, okay. What about
So I
the
think
fourth one, sir? Fourth one, what it is saying?
so. Fourth one says that important features selects desired number of important features as specified by the max number of features above certain threshold
Uh,
of feature importance as obtained from the trained estimator.
okay, okay. It's a the different one, right?
Yeah. So what it is
Yes,
saying
okay.
is you already have a number which is the threshold for feature importance. So all the features which are not important or do not cross that threshold will be removed. This is what the meaning of fourth point is.
Okay, okay. Yeah.
So I think 2 and 3 should be correct.
So why
So
it is
recursive,
like they have used the name wrapper and filter, sir? I mean, it is confusing. I mean,
okay,
filter
substitute features
based.
by starting with all. Where is filter?
No, no, sir. I'm just saying. I mean, the feature like the wrapper based feature selection and the filter based feature selection, right? The
Yeah, so
names.
one of them is true, and it is not a filter based feature
Yeah,
selection.
yeah. No, no. I'm just saying like the name. Why they've used like filter based feature selection and wrapper based. So the filter base is like only use the features, right? And wrapper base use the model also.
Absolutely. Yeah. So let's look at RFE. Okay. So given an external estimator that assigns weights to features, for example, linear regression model. Okay. The goal of recursive feature elimination is to select features by recursively considering smaller and smaller sets of features. Once the estimator is trained on the initial set of features and the importance of each feature is obtained either through any specific attribute or callable, then the least important feature are pruned from the current set of features. That procedure is recursively repeated on the pruned set until the desired number of features to select is eventually reached.
Okay. Yeah.
And because I think for that, I think this is the correct answer,
Yes, sir. Yeah. Now it makes sense.
right?
So how does RFE works on code?
How RFE works on?
When we code, how does we use RFE?
Good point. So whenever you want to see some examples, click on the user guide of from its documentation page. There you go. Oh,
So
by the
could
way,
you please
this is
explain any one of the example here?
yeah, sure. So RFE is not specifically good point. So example of it is not over here, but calling it is should be like very easy. Maybe one example over here. Yeah, there it is. Okay, so what we do is there is some data set. How it is coming out to be, you don't have to worry about. Right now, it is generating the data set. Now we choose an estimator. It could be something else also, which assigns, remember the point, which assigns weightage to each and every feature. We initialize the parameters of it. So SVR is nothing but support vector regressor. So if you remember a support vector machine, it's based on that paradigm. This API is based on support vector machines. Then we choose selector, which basically a variable for this feature selection API. We choose the estimator. We choose the number of features to select, and we call the number of steps is equal to 1. That means in every call, every time it runs, it removes the least. Okay, to be sure, I think it removes the least important feature. Okay, give me one more step. Yeah. Right. I was right. So if you say step is equal to 1, so in every so let's say first iteration is run. What you do is you fit an estimator on the data, okay, and this estimator is going to give you the weightage for every feature, all right, and step is equal to 1. So RF is going to look at this value, which is 1. So once first round of training is complete, it's going to remove step number of features from all your features. Okay.
Yeah. So the least.
All right.
So
So this is
suppose there are 50 features. So step 1 means one iteration. Is it true?
now step 1 means in every round of training, how many number of features you are allowed to remove.
Okay. So we remove one feature.
Right. We remove one feature.
So we are left with 49.
Exactly.
And so what does this n features to select means? We are selecting 5 features out of 49. Is this?
Yes.
Okay.
Sir,
Okay, rest of them will be
it,
removed.
it removes features based on the weightage given by the estimator.
Right.
So how it is given? I mean, what kind of weightage is given, sir?
So
Let's say
for
where you,
simplicity, let's talk about so SVR can be represented by an equation. Is that right? Support vector machines.
represented by sorry, sir, what you say?
An equation.
Yes, yeah.
Right. An equation. The what should I say? The features are linear combination of right. So the left hand side is the label, and right hand side is some function of linear combination of features. Is that correct?
Yes, yeah.
Right. So when you take the linear combination of features, or even for simpler understanding, instead of SVR, consider linear regression model, which is
Yeah.
exactly this. Y is equal to linear combination of features.
Yes.
Okay, so the linear combinations, the coefficients of every feature is going to give you the importance of that feature.
Okay, yeah.
Okay, so the lower the value of the coefficient of a feature, the lower it will sit in the list of importance.
Yes.
Okay, and that's how it works.
Okay, sir. So what is the SBR? I think SBR is not taught in MLT, sir.
No, so support vector machines are typically taught as
Classification.
classifying models, right?
Yeah.
Yeah. So SVR is actually a variation of that. It is definitely based on support vector machines. You can look it up how it works.
So what does random state signifies, and what does its value signifies?
Good point. So random state, see, whenever you're, so this function, how it internally works, I don't care, but it randomly generates some data points, not uniformly randomly, by some mechanism, some Friedman one mechanism. Okay, but to start generation, it has to feed on some random value. Okay.
So how it is generating randomly, because we are taking make Friedman is somewhere a file, a CSV or anything that we are taking into consideration about this code. But again, we are saying this, we are generating it randomly. So how it is like, I didn't understand it.
Okay, so make Friedman function uses randomness to generate some of the some, not some, but the data that you want. Okay,
Okay, so it's not any file here.
it's not, there's no file in here, absolutely not. This is actually a function. So I think from data sets, yeah, there it is. From data sets, this function is being imported. So if you want to look at the there it is. Yeah, Friedman number one. So I think you can also look at the procedure by which it generates the data. But okay, let me take a simpler example. So this is data generation process. Assume that you want to generate 10 data points from a standard normal distribution. How will you do that?
We can
Hello?
use NumPy.
Right. So how does NumPy do that? Now, because we are talking slightly deeper.
It uses that normal distribution function.
Which function?
Normal distribution. I mean the PDF.
Right. It definitely uses normal distribution, the mathematical model, definitely. But how?
Okay. So what is the question? I mean, you think?
How the, so let me ask you this question in different manner. Let's say you generate 10 random values from a standard deviation, normal standard distribution, and
Yeah.
your friend also generates the 10 uh, 10 randomly generated values from standard normal distribution. Okay,
Yes.
will they be same?
No. Different.
They will be different, right?
Yes.
But how
Yes.
they are different? You are calling the same function.
Okay. So there is a, I think, is a sample, right? I mean, from population of data, it is just getting the sample one. So the
See,
sample can
all
be
these
different.
all these functions which generate data by some random process, uh, there is no function in computer science which uh, you know uh, which generates random numbers on its own. It feeds on something. So typically it feeds on the date time at which the timestamp of the computer system on which it was executed or called on. Okay, so all the random number generators do not feed on any. They seem like, they don't take anything and gives us random numbers, but they actually take the system and then produce the output. And the system time changes very quickly because computers can feed on milliseconds or even nanoseconds of data. Uh, that much resolution of time they can read. Take that is input and generate the random numbers.
Okay. So
Does it make sense?
that, that's why they call it pseudo random.
Absolutely. Yes, they call it pseudo random numbers.
Okay. Okay.
Now, coming back to original question, why random? What is this random state? So random state is that input to your random number generator. or any function which uses randomness in some sense. Okay.
Yeah.
So if you look at the question, where is it? Friedman. Okay, somebody asked Friedman. Where is it? RFE. There it is. Friedman. So this function uses randomness inside to generate these data points, and for that, this random state is actually the number which feeds the starting the number which is the input to the random process, and then it generates 50 by 10 data. By choosing this number, random state is equal to 0, and specifically giving this every time you run this function, it is going to take random state is equal to 0. That will be the number fed to the random process inside this function. So every time you give a random state is equal to 0, it is going to give you the exactly same output. Okay. So why is it done? So that you can repeat the experiment. Okay. You execute this function, you get the data, you see stellar results. Okay, you're not sure why is it happening, but you want to investigate further, and for that you want to freeze your input, not change it across multiple runs. So in that case, what you do is you set a random state is equal to some constant number. It could be 0, 42, something else. Okay.
So, sir, every value has the same meaning,
Every value has the
same significance here, because we are fixing the randomness of some random function here.
Hmm.
So
What?
if we say random state 0, we say random state 42, anything, this means we are fixing it. It doesn't signify, the values doesn't mean like anything specific.
Absolutely. Yeah, they don't mean anything specific. We are just freezing them. Yeah. Any other question? All right, let's move on. So question number 2. I'm not sure we'll be able to finish all of them today, but let's see. Let's try. Question number 2. The argument of the parameter threshold is the class select from model can be integer, mean, median.
Integer, mean, and median. I think 3.
All 3 of them?
Yeah.
Okay. I'll take you for your word because I don't recall what the exact value for the parameters for this is. Okay. Any dissenting voice that one of these options is not correct? None. Okay. Let's go ahead then. Question number 3. Which approach is used in the class sequential feature selection? Only forward selection approach? Only backward selection approach? Both forward and backward? None of these.
So
Both forward and backward.
Absolutely right. It allows you to do both. One quick question. Let's say if I have a data set and I freeze the randomness of the process either way, forward and backward. So let's say if I choose 5 features out of 10, will I get the same answer if I go forward as the same as the answer if I go backward?
No.
Okay. Any takers for yes?
Okay. So you are saying uh, the freezing the random state, right?
Yeah, freezing the random state so that your experiment is reproducible. Yeah.
Okay. So finally we are selecting only five features.
Out of 10 or out of 100?
Yeah. It will be same. Yeah. It will result same.
No, it not necessarily be same.
Why is that? Because finally we are having only 5 features, right?
Right. But we are progressing in a very different manner. Once, if we are moving forward, we are increasing the number of features. If we are going backward, we're reducing the number of features.
Okay. Yeah. Okay.
See, what it does is it does a greedy approach. So this is the point to remember. It follows a greedy approach to remove or add. That's all. So the greedy approach never sees one step or two steps ahead. It only sees the immediate result that it has. And because of that, it is possible that we get different answers if we move forward and if you move backwards. All right, let's get back to our set of questions. Question number 4. If you want to select the 3 features out of 10 features using sequential feature selection, which approach will be more reasonable? Forward selection or backward selection?
So forward.
And why is that?
So because we need less number of iterations when we do forward selection.
Absolutely right. Yeah, this should work.
So could you please explain select from model, because I have doubt in this function select from model.
Okay. Yeah, tell me.
So how does this work? I didn't understand anything about that select from model.
Okay. So as a general comment, even I do it plenty of times, that whenever you have doubt about any particular API, just look at the documentation and see how it works. Okay.
Okay, sir.
Right. So I think this is something of improvement of RFE and multi-iteration feature selection wrappers. Okay. See, what it does is, so recursive feature elimination, it iterates, and every iteration it chooses let's say 1 or 2 or few more number of features to remove. Sequential feature selection also does the same thing. Every iteration it adds or removes a certain number of features. It actually fits a model before it does that. In select from model, I think it does it only once, and because of that, it's different from other methods. See this one. The base estimator from which the transformer is built. This can be both a fitted or prefit or non-fitted estimator. The estimator should have feature importances or coefficient attribute after fitting. So these arrays or this attributes of this model of the whatever estimator you're using. It should have one of these two, and this information is used to figure out what are the important features and what are not. Okay, and what is the threshold? Now look at this. Feature importances gives us the importance of each and every feature in the data set, and threshold, by specifying threshold, we mentioned that any feature which has lower than this threshold, importance of that feature is lower than the threshold, just remove it, something like that. Okay.
So, sir, the coefficient and the coefficient is we got the we get the coefficient from the model, right? The trained model.
Trained model, yes.
Fitted model, we get the coefficient, and based on the threshold value, we can remove. I mean,
Yes.
so it is similar to the RFE, but there we didn't use a threshold. There we only remove like step by step, like one.
Right, absolutely right.
Okay.
So here also we are removing the features.
Correct, we are doing so.
So how we are saying the function is, the estimator is like select from model. So what's the use of model here?
So tell me this: how many times will this estimator be trained on the data in select from model?
So
Only one time, yeah.
Only one time. And what about sequential feature selection?
It will be
multiple times.
Multiple times. So this is the difference. The approach, the computation time, both are different.
Okay, but they are bringing the same output, like both of these.
I wouldn't say that they always will produce the same output on same data set.
Okay, so they might differ also.
Of course.
Okay, sir. Fine.
Sure. Let's come back to our set of questions. All right. Now comes a very important part, which is how to deal with heterogeneous features, and which is very, very common. Absolutely, this is an absolute skill to build a good machine learning pipeline. How to deal with heterogeneous features. When we say heterogeneous features, which are ordinal, categorical, numeric, different, and also with different ranges, missing values, and everything, all kind of distortions or problems you can imagine are there in your data set. And how would you build a single uh, uh, object, which is a pipeline object, to deal with all of them, and doing that with very good consistency. And how would you do this very, very easily? So, okay, I'll tell you one example. So you have seen examples of transformers, one-hot encoding, as well as scalars. So I saw recently a notebook of a student who showed me what he was working on. And instead of creating a pipeline, there were 20, 30 features. Every feature he had transformed by hand. For every feature, he had written a line to transform it and store it back into the data frame. Okay. So first of all, this is very, very time consuming and prone to error. If there are these many number of features, more than 20, even there are 5, I would use a pipeline, because it makes your code look very organized, and it is very less prone to errors. We'll see some examples in the demonstration maybe. So here comes a very important concept. I just want to stress that dealing with heterogeneous features using pipelines is a very good thing to learn. Okay, first question is, which of the following modules in sklearn deals with applying transformation on data set on subset of diverse features, such as numerical and categorical features, or both?
So sklearn.compose.
Absolutely right. Okay, look at this data. What will be the output of the following code? Okay, so what we have is, one is we have a column transformer. Okay, then we have min-max scalar and ordinal encoder. Okay, this is our data. So it is a 3x2 data, 3 rows, 2 columns. By looking at it, first column is numerical, second column is categorical, definitely not numerical, and see what happens. Column transformer, we define that. And so, by the way, what is this? Can anyone tell me? What is the input of column transformer?
Sorry, sir.
What is the input to a column transformer?
List of tuples.
List of tuple. And what is a tuple? What does each tuple represent?
The name of the
Transformer.
transformer, yeah. Name of the transformer.
Yeah. Next.
And another
Next.
the method. I mean the object.
The
So
right?
your voice is breaking.
Okay. How is it now? Am I better audible now?
Yes, sir. Yeah.
Okay. So what is the second object? The second item in this tuple?
Second item is the
The
class name.
operation
Class.
So the scaling function.
transformer.
Transformer, right? The name of the object for the transformer.
Yes.
Right? And what is the third item?
It's the column number.
Absolutely
number.
right. The column number is starting with index 0. So what does this going to do is, it is going to apply min-max scalar on column 0 and produce a one column. Okay. Then there is a second tuple. What does this mean?
It is not applying anything. I mean.
Correct.
Nothing
Just
else.
copy paste, copy the input to the output. All right. Then there is one not in. This is encoder. Third tuple is one not encoder. Which column it applies to?
Second one.
Second one. Absolutely right. Right. So the first transformer is going to min-max scale the first column. The second transformer is going to just copy paste the first column, and the third transformer is going to ordinarily encode the second column. Okay. So, by the way, what should be the output of what will be the shape of the output of this uh, pipeline?
Column should be 0 to 1.
Three, what
3
will
by
be the
3.
output?
First
3
So
by
column.
3 cross 3.
correct, 3 by 3, because ordinal encoder only gives one value for every value inside input vector, right? Correct.
Yeah.
So 3 by 3 should be the output. Now, first one is scaling, min-max scaling. What should be the output for this? 0, 1, 2.
Sir,
So
one thing.
first one might be 1 minus 1
1
upon
minus 1,
2.
0.
Yeah, it
Which
will
is
be
0.
0. Then 2 minus 1 upon 2, that will be 1 by 2, that is 0.5. And 3 minus, then third one would be 1.
Right. So 0, 0.5, and 1.
5 and 1. Yeah.
Correct. So let's see, where do we find that? We find that in option number C and D.
Yeah.
Okay. Now,
So what is the name doing there? I mean, the scalar, pass, and encoder. We can change it, right? We can name it
yeah,
anything.
you can change it according to yourself. Yeah, no problem.
Also, we can put order in ordinal encoder also. Like you can in categories, we can put orders also in ordinal.
Yeah, of course, of course. So these names that you provide, it's up to you. They are not, they have meaning only to you, but not to the pipeline that you built.
So where
And,
we'll be using? I mean, where you are
good.
naming it?
So have you looked at how would you visualize your data pipeline?
No, sir. I have not watched that video yet.
Okay, so do watch them, because let's say if you have a data pipeline which have many steps, 10, 15, or 20, you might forget, okay, which component belongs to so this component in the code belongs to which item in the data visualization of the pipeline.
Okay.
Okay, we'll see that. I think it's going to come.
Yeah, in the last, I think last.
Yeah, somewhere it should come. Demonstration of data transformer, composite transformers, data visualization. Okay, this is different. Okay, it'll definitely come. Okay. All right. So
Sir,
what should we, yeah.
Sir, I have one question here.
Yeah.
So if I skip that second line in the column transfer over pass through, is it still going to produce same outcome?
Yeah, definitely. It is what it is saying is
Uh-huh.
select column number 0. Okay, and instead of the name of the transformer, we are just mentioning a string pass through. It is going to what it means is don't do anything to this column and copy paste it, copy from the input and paste it in the output.
Okay, got it, sir. Thank you.
Yeah. So what should be the correct answer, C or D?
So D.
D. Okay, so the difference is only in the last column, 110, 100. Let's see. Okay, yes, no. So it definitely should be 100. Correct.
So your ordinal encoder has been encoding this yes as 1 and no as 0. Suppose we want to reverse the thing. Like we want to encode yes as 0 and no as 1. How should we do that?
Interesting question.
We
Let's look at
can
the
put categories, sir. We can put categories in a list of a list. We can put.
there it is.
And it will be in descending order.
Right. So whatever order we choose, that's the order it will also accept. Okay, does it make sense?
Yes, sir.
I don't think we are going to see an example of categories. Yeah, that example is not over here, but you can definitely try this.
Okay, sir.
Yeah. All right, so D is the answer. I think we are done with this. 2.6. Okay, now let's go to question number 2. Activity question is 2.7. So don't worry if we are not able to finish all of them, because we're going to continue from the point where we leave today. in the next session. Question number. So this one is about dimensionality reduction. Okay.
Sir,
Yes.
we are not going to do practice assignment today, or are we?
I'm afraid we might not have time for that.
Right. So when is the next session?
It is on Saturday.
Right, right. Good.
Okay. So question number 1. Which module in sklearn is used for dimensionality reduction techniques? sklearn impute, feature selection, compose, decomposition.
So it's a decomposition.
Okay. By the way, is the name correct? I find it. I think it is decompose. Okay, it's decomposition. Maybe remembered from somewhere else. Okay. Question number 2. Which of the following statements are correct about the principal component analysis? It's a linear dimensionality reduction technique. It uses singular value decomposition to project the feature matrix or data to a lower dimensional space. It uses stochastic methods to project the feature matrix to data to lower dimensional space. The subsequent PCs are orthogonal to the first PC.
So options are 1, 2, and 4.
Correct. This one is incorrect. Everything else seems correct. Yeah. So see, we are not going into the details of how it is computed, how it looks like, because those things you must have covered in MLT, as well as some of it in the video lectures. Okay. All right. Any questions so far? All right. Let's go to question number 2.8. So the topic of this will be chaining transformers. If you want to create complex transformers, how will you do that? So question number 1, what task does the module sklearn.pipeline do?
I think first one, sir.
Right. So remember that pipeline only a pipeline object, which is, so when we say data pipeline, it's a logical concept which can include pipeline API, which can include column transformer API, which can include feature union APIs. Okay. Here we are talking about pipeline object. So pipeline object or pipeline API only allows you to create pipelines in a sequential order. You cannot, create them in parallel. For that, you will have to use column transformer and feature unions. Question number 2. What will be the output of the following code?
So I think it's 3.
Okay. Can you tell me why?
So because we are using three impute. First one is simple imputer, then PCA, then linear regression. We are having 3 objects in our pipelines. That's why the length of pipe steps would be 3.
Absolutely right. That should be correct. So now I have a question. If I call pipe.fit transform, what will it do?
It will learn and transform based on the imputer, and also it will try to do the feature extraction. What is called feature selection, right? PCA, and also do the also implement the model.
Okay, so let me rephrase my question. You're very close to the answer. When I call pipe.fit transform, would it accept only one argument or 2? So should I call it fit transform X or should I call it fit transform x comma y?
X comma Y,
X comma Y, sir.
Why is that?
because we're using the model also. I mean, regressor model
But there
also
is
will use.
PCA also. There's simple imputer also inside it, right?
Yeah, but for regressor we need, right? I mean,
But why
input.
only the regressor? Because of the regressor, you're saying that x comma y.
Yeah.
Okay,
Because of the regressor I'm saying.
right. You are actually correct. So the pipe object itself exposes the APIs which are available in the last step of the estimators. Okay. So simple imputer is first, second is PCA, third is linear regression. So all the APIs which are in linear regression model, all the functions or attributes that you have in linear regression model can be called on pipe dot.
Pipe
Okay.
dot. Okay.
Question number 3. What are the two ways to create a pipeline object?
Sir, I have a doubt. I mean,
Yeah.
so the column transformer is also a pipeline object. When we use column transformer, so it will also do the same, right?
When we create a column transform, it will do all the same thing. Not sure. No, it
In the the activity section we did, right, the column transformer, and then we
But so generally, column transformer does your transformation part, not your model fitting part is not for
so I have a little
oh,
confusion there.
here's the column transformer. Yeah, tell me.
Yeah. So here also it is. So first it is doing the uh, scaling,
Right.
uh, and then the scoping, and then encoder it is.
Correct.
Yeah. So what,
You're saying both of them are
how it
doing the
is
same.
different than the pipeline?
Correct. Good question. In the pipeline, you can never choose which columns to apply the transformations on.
Okay.
Okay. See this pipeline. Here, there's nothing like that. You're not choosing. So you're assuming. So this pipeline, whatever data you applied on, it assumes that all the columns are numerical.
Oh.
Okay. So this is the biggest difference between this one and the column transformer.
So the
Here,
pipeline will work on all the, I mean, the entire data it will work.
absolutely. So pipeline is, what sequence of things. Here you are applying, you are creating parallel outputs,
Yeah.
right? So that's the
Yes.
difference.
Okay. Yeah.
So in that previous question, when we are applying fit transform, what was the answer? I didn't understand.
Previous question, you mean the pipeline question?
Yes,
This
sir, the
one,
pipeline one.
right? So what I
PCA
meant is
linear.
the attributes and functions available to this object will be exposed by pipe object, because this is the last step in the sequence of estimators.
So, sir, the last one is what we are interested in. Is that so?
No, it's not like that we are interested in the last one. It's like, uh, logically, what would you do is you definitely do the data pre-processing and then fit the model, right?
Yeah, yes, sir.
So what happens is, whenever you call fit transform x comma y, it will do everything on simple imputer and PCA also. It will apply simple imputer and PCA on x already before making the predictions or training the data.
Okay, because of these two steps of data pre-processing, the simple imputer and PCA.
Right. So
And
by
then
the
in
way,
linear regression, we have the two X and Y.
right, excellent, exactly. And one mistake I made, I would like to make one correction. Linear regression would have fit method only, not fit transform, because it's not a transformer, it's an estimator.
Yeah, okay. So it's just learning out from this and it's not applying it anywhere. That's why you are saying that.
No. What I'm saying is, when you call pipe.fit x comma y on x, it will execute these two steps. And whatever the output of these two steps will be, that will be fed into linear regression model, and y, which you have called on pipe dot x comma fit x comma y, will be provided to this object.
Sir, but for PCA and simple imputer, we have to transform also, right?
Yeah, they will transform also.
So
So
only
linear
like
regression model, this model is going to get transformed the data.
okay.
And what is the use of this? The biggest use of pipeline objects. Now imagine you have to make prediction on test data, right?
Yeah.
And for that, you would like to apply the same transformation that you have applied using these objects, that you have learned using these objects on training data on test data. So when you call pipe.predict, it is going to transform the data, the test data or test feature matrix using these two objects, and then make the prediction. That transformed test data will be fed to this model, which is already trained because you've called fit already on trained data, and then this transformed data plus that this transformed data will be used to make the predictions.
So
So
let's say here, sir, I will.
Mhm.
Yeah. So like if we in this code, if we write pipe dot fit,
Mhm.
so it will first feed the simple imputer and PCA, and then transform the data, and after that it applies the linear regression.
Correct, correct,
Okay, so it's automatically transform also, right? Uh,
exactly. Yeah,
Without
that is the
calling
point.
the transform. Yeah. Okay. Okay.
Yeah. See,
Okay.
what is the beauty of this one? There could be, let's say, right now there is only simple imputer and PCA. What you would have inserted a few more steps, but okay, let's stay with this one. So if you did not build a pipeline, you would have to apply simple imputer to original X. Then they create X underscore imputer. Then you apply PCA to X underscore imputer, and then you create, let's say, X underscore dimensionally reduced. And then you pass this X dimensionally reduced transform data to linear regression model, right? So you had to write all these steps on your own, correct?
Yeah. Yeah.
Then once when you want to make the predictions, you would call simple imputer dot transform on test data.
Yeah.
Then this imputed test data will go into PCA
Again. Yeah.
step, and then
Okay.
you feed it to linear regression model for prediction.
Yes.
That would be very, very difficult to manage, especially when the your data pipeline, the logical data pipeline gets complicated and very easy to prone, very prone to make errors.
Yeah. So here we like reducing the steps. I mean,
Yeah,
only.
we create a good pipeline like this
Okay.
and just reuse it again and again.
Sir, if any new data added, though automatically pipeline will train themselves automatically, or
So where are you adding this new data? Training set or test set?
suppose in training set.
See, if you have new data to train on, definitely you have to re-execute the entire pipeline, right?
Okay, okay.
Yeah. Okay.
But sir,
One,
if it is on test set, then we don't need to do this again, the whole pipeline to re-execute.
yeah, definitely. We just on test set, we always call predict.
Yeah. Okay.
All right. Question number 3. What are the two ways to create a pipeline object?
Pipeline and make pipeline.
Absolutely right. So first argument, first option, pipeline accepts the name of the steps also. Second one does not. Am I correct?
Yes.
Okay.
And what should you use, sir? Pipeline or make pipeline?
I would prefer pipeline. I typically prefer pipeline. Personally, I prefer pipeline, but make pipeline is a shorthand method. Maybe will save you a few keystrokes to build the pipeline. Okay. Question number 4. Which of the following statements are correct about the sklearn.pipeline.feature union? It provides utility to utilities to build a composite estimator as chain of transformers and estimators. Okay. It concatenates results of multiple transformer objects. It lists the list of transformer objects can be executed in parallel. It provides the utilities to build the estimators only on test sets.
Second and third option.
Absolutely right. Point number two. Point number three.
Sir, I have one small question here.
Yeah.
I think similar to feature union, I think the column transformer also doing the same job, right? Maybe can you help me understand if there are any differences between this column transformer and feature union?
Hmm. Good point. Uh, let's look at the example.
Sure, sir.
Yeah. So PCA, SVD, triggered components. I have to. Okay, it has been some time. I'll have to go back to and do a bit research coming back to this, but definitely there is some difference
Got it, sir.
where feature union is used and just not the column transformer. Let me think about it.
Sure, sir.
Yeah, I would request you to post a question on the discourse. Let me look into this question. This is a really important, good question. I have to look into this and reply to you.
Sure, sir. I will post. Thank you, sir.
Sir, I think feature union is used on the entire data, right? And column transformer can be used like the column wise. You can use it
Right,
for a
right.
particular feature.
Okay, so you're right. We're right. So let's think about this one, right? So feature union is this. Oh, okay, okay. But again, I'll dive deep into this.
Yeah.
Feature union. Okay, okay,
Even the
right.
example only I'm saying. I mean the examples that we've seen so far.
Right. So what this says is this is the input. So PCA will be applied on this entire input, and whatever the output will be, it will be put as the first set of columns. Okay, and what will be whatever the output of this estimator or this step will be, it will be juxtaposed or put side by side with the previous output.
Yeah, parallelly. I mean it will.
Right, parallelly. So
Yeah.
one benefit that you get from using feature union is you can these steps of feature union are run parallelly, and pipeline steps are executed one by one. Okay, but there should
Yes.
be a bit more a difference between feature union and column transform. Let me look into this. All right, we are at the end of our time limit. So this particular chapter covers a lot of things. So it's okay if we are spilling over to next session. Next session, it will be a little longer because we are going to be doing a lot of things. Not only finishing this and also writing code and solve problems and see the outputs of our code. So it is possibly going to be longer than 2 hours. Yeah, just a heads up.
Sir,
Excuse me, sir. I have a question. I mean,
Yeah, sure.
sir, like, is there any separate discourse channel for the project?
Yes,
yes,
there
sir.
is. Yes, there
So
is.
I'm not in that channel yet. I mean,